Hello, Math 142. Um, we are going to convert some polar equation to rectangular form. Uh, these problems are coming straight from directly from your textbook, so I have to give credit to Stewart, Redlin, and Watson, the authors of the textbook. Suppose I have something as simple as r equals 6 cosine of theta. And I would like this right here. It would make my life easier if I had r squared in here. So what I'm going to do, I'm going to go ahead and multiply both sides of this equation by r. If I do that, so multiply both sides of this equation by r, I would get r squared equals 6r cosine of theta. Okay. And now I can exchange r squared with x squared plus y squared, because x squared plus y squared equals r squared. Okay. And that equals 6r. And I know r cosine of theta is x. So I'm going to exchange this with 6x. Okay. Okay, what can you do? Let's move the 6x to the left-hand side and go x squared plus y squared. Uh, Let me put the 6x right here. Minus 6x plus y squared equals 0. And now I can complete the square in this part. Okay, half of 6 is 3. And 3 to the second power is 9. So I need a positive 9 in here. I'm going to add 9 to the other side. So this becomes x minus 3 quantity squared plus y squared equals 9. Okay, x minus 3 quantity squared plus y squared equals 9. And if you remember, this is a circle with radius of 3, and uh, well, the center of the circle is at 3 and 0. Okay, let's do a couple of more of this type. Suppose we have something like r equals r equals um, 3 times 1 minus sine of theta. Okay. Well, first of all, this is the same as saying r equals 3 minus 3 sine of theta. And as usual, I like to multiply both sides of this equation by r. So it will give me r to the second equals 3r minus 3r sine of theta. So what I did, I multiplied both sides of this equation by r. Okay. So now I can claim that this is the same as r to the second, okay, plus 3r sine of theta equals 3r. Let's score both sides. Let's score both sides of this equation, okay? And that will give me r squared plus 3r sine of theta squared equals 9r squared. Okay, and if I expand this, I get okay. Okay, this is x squared plus y squared. Okay, because r squared is x squared plus y squared, and plus 3 times r sine of theta is y. All that to the second power equals 9r squared. And what I can do with this is actually, if I keep expanding this, this is going to be, fairly large. So I'm going to stop right here, and I'm going to one baby thing I can do in here, that I can exchange my r squared with x squared plus y squared. Okay, good enough. Let's see, do we have, let's do another one from your own textbook. How about r equals r equal 2 minus cosine of theta. So multiply both sides of this by r. That gives me r squared equals 2r minus r cosine of theta. Okay, let me exchange color, and then I can rewrite this as r squared plus r cosine of theta equals 2r. So now I'm going to go ahead and score both sides of this. Okay. Then I'm going to get r squared plus, well, let me exchange the r squared with x squared plus y squared plus r cosine of theta, of course, is just x. And all this going to give me quantity squared equals 4r squared. Okay. And I'm going to keep this in the same format. X squared plus y squared plus x to the second power equals 4. And we said r squared is x squared plus y squared. And yep, we are happy with that. That's good enough. Let's do one more. Let's do, how about r equals 1 over 1 plus sine of theta. Okay, so here I can just cross multiply or multiply both sides by the LCD. I get r times 1 plus sine of theta equals 1. Okay, so which is the same as, now if I can multiply this, distribute this, and say that r plus r sine of theta equals 1. And how about, let me get this r by itself. So I go r equals 1 minus r sine of theta. And we know that r sine of theta is y anyways. And if I score both sides of this, I get, yeah, let's do that. And let's score this side and score that side and see if that's helpful. So that this is r squared equals 1 minus r sine of theta squared. R squared is same as x squared plus y squared, and this is going to be 1 minus y to the second power. Okay, so now I have x squared plus y squared equals 1 minus 2y plus y squared, bringing I can just drop the y squared from both sides. So I can say x squared minus 2y minus 1 equals 0. Well, I hope you found this, I hope you find these examples helpful. And that's all I have to tell you for now. Thanks.